In this video, we are taking a look at Wankel rotary engine, radial engine, and rotary piston engine in details, starting with Wankel rotary engine. The Wankel engine is a type of internal combustion engine using an eccentric rotary design to convert pressure into rotating motion. The German engineer Felix Wankel invented the rotary engine known as the Wankel rotary engine. In a rotary engine, the pressure of combustion is contained in a chamber formed by part of the housing and sealed in by one face of the triangular rotor, which is what the engine uses instead of pistons. Compared to the reciprocating piston engine, the Wankel engine has more uniform torque, less vibration, and for a given power, is more compact and weighs less. The engine is commonly referred to as a rotary engine, although this name is also applied to other completely different designs, with the piston ones, that is also known as rotary piston engine. And now, let's take a look at the different parts of a Wankel rotary engine. The housing. It is an oval-like epitrochoidal-shaped housing enclosing a triangular rotor with bow-shaped faces that resemble a Reuleaux triangle. The housing consists of an inlet port, outlet port, spark plug, and water jacket, etc. A rotor. The rotor consists of three convex faces. Every face acts as a piston. The rotor works as a prime mover in the Wankel rotary engine. The combustion is generated by burning the fuel and is applied directly to the rotor, so it spins eccentrically. The rotor lobes are sealed tightly against the sides of the oval chamber. The combustion of rotor and chamber shapes ensures that they remain in contact with each other throughout the rotation. On one side of the rotor, it has an internal gear that meshes with the fixed gear located on the side housing to keep the correct connection between the rotor and the eccentric shaft. The central drive shaft, called the eccentric shaft or E-shaft, passes through the center of the rotor, being supported by fixed bearings. The rotors ride on eccentrics integral to the eccentric shaft. Spark plug. The Wankel engine uses two spark plugs, that is, a leading and a trailing spark plug. Since the combustion is pretty long, two spark plugs are always required to spread the flame. A rotary engine has an ignition system and a fuel delivery system that are similar to the ones on piston engines. And now, let's take a look at the working principle of a Wankel rotary engine. Rotary engines use the four-stroke combustion cycle, which is the same cycle that four-stroke piston engines use. But in a rotary engine, this is accomplished in a completely different way. As the rotor rotates orbitally, revolving, each side of the rotor is brought closer to and then away from the wall of the housing, compressing and expanding the combustion chamber like the strokes of a piston in a reciprocating piston engine. If you watch carefully, you'll see that the output shaft spins 3 times for every complete revolution of the rotor, which means that there is one combustion stroke for each revolution of the output shaft. Now let's go through each of the 4 strokes of the engine, looking at one face of the rotor. Starting with intake. As the rotor moves past the intake port, the volume of the chamber expands, drawing air or fuel mixture into the chamber. When the peak of the rotor passes the intake port, that chamber is sealed off and compression begins. In compression stroke. As the rotor continues its motion around the housing, the volume of the chamber gets smaller and the air or fuel mixture gets compressed. By the time the face of the rotor has made it around to the spark plugs, the volume of the chamber is again close to its minimum. This is when combustion starts. In combustion stroke. The spark plugs ignite the air or fuel mixture. Pressure quickly builds, forcing the rotor to move. The pressure of combustion forces the rotor to move in the direction that makes the chamber grow in volume. The combustion gases continue to expand, moving the rotor and creating power until the peak of the rotor passes the exhaust port. In exhaust stroke. Once the peak of the rotor passes the exhaust port, the high-pressure combustion gases are free to flow out the exhaust. As the rotor continues to move, the chamber starts to contract, forcing the remaining exhaust out of the port. By the time the volume of the chamber is nearing its minimum, the peak of the rotor passes the intake port and the whole cycle starts again. The rotary engines, each of the three faces of the rotor, is always working on one part of the cycle. Now let's take a look at advantages of Wankel engine. In principle, Wankel engines are ideal for light aircraft, being light, compact, almost vibrationless, and with a high power-to-weight ratio. Having no reciprocating parts, there is less vulnerability to damage when the engine revolves at a higher rate than the design maximum. The limit to the revolutions is the strength of the main bearings. There are a few disadvantages of rotary engines. It's more difficult to make a rotary engine to meet US emissions regulations, and the manufacturing costs can be higher. Rotary engines also tend to consume more fuel than piston engines. Motorcycles that use Wankel engine. The first Wankel engine motorcycle was the 1960s IFA-MZ KKM 175W, built by German motorcycle manufacturer MZ and licensed by NSU. The Hercules W2000 is a motorcycle made by Hercules in Germany. It was the first production motorcycle with a Wankel engine designed in the late 1960s that produced 27 to 32 horsepower at 6,500 RPM with a top speed of 90 miles per hour. Norton spent most of the 1970s fiddling with prototype rotary-powered bikes, but it took until 1984 before finally creating its first production Wankel engine motorcycle, the Norton Interpol II, as a police version. Subsequent Norton Wankel bikes included the Norton F1, F1 Sports, RC 588, Norton RCW 588, and NRS 588. From 1975 to 1976, Suzuki produced its RE5 single-rotor Wankel motorcycle. It was a complex design with both liquid cooling and oil cooling and multiple lubrication and carburetor systems, having a modest power output of 62 horsepower. Cars that use Wankel engine. Many Mazda cars include Mazda Yunis Cosmo, Mazda RX-7, RX-8, RX-500, Mercedes-Benz C1112, Citroën M35, and Citroën GS by Rotor cars use the Wankel engine. The Mazda RX-8 Hydrogenari is a bi-fuel version of the RX-8 sports car built in 2003, in which the twin-rotor Wankel rotary engine is configured to run on either hydrogen or gasoline. In the racing world, Mazda has had substantial success with stock and modified Mazda Wankel engine cars. The Sigma MC74, powered by a Mazda 12A engine, was the first and only team from outside Western Europe or the United States to finish 24 hours of the 24 Hours of Le Mans race in 1974. The first Wankel rotary engine aircraft was in the late 1960s, being the experimental Lockheed Q-Star civilian version of the U.S. Army's reconnaissance QD-2, essentially a powered Schweizer sailplane. The plane was powered by a 185 horsepower Curtiss-Wright RC-2-60 Wankel rotary engine. The same engine also used in a Cessna Cardinal and a helicopter in Germany in the mid-1970s, a push-ducted fan airplane powered by a modified NSU multi-rotor Wankel engine was developed in both civilian and military versions, fanliner and fantrainer. Wankel engine in electric vehicles. This time, the rotary engine itself will not actually propel the car. Instead, it will generate electricity to power the electric motor and other systems in the car. However, the Mazda 2 EV uses a Wankel engine as a range extender. The engine is a tiny, almost inaudible, single-rotor 330 cubic centimeters unit, generating 30 horsepower at 4,500 RPM and maintaining a continuous electric output of 20 kilowatts. Radial piston engine. The radial configuration was commonly used for aircraft engines before gas turbine engines became predominant. They are the powerhouses of early aviation up through the beginning of the jet age. These engines are amazing. But why were they invented and how do they work? Let's find out. Charles M. Manley constructed the first 5-cylinder water-cooled radial engine in 1901. It is a conversion of one of Stephen Balzer's rotary engines for Langley's Aerodrome aircraft. Meili's engine produced 52 horsepower at 950 RPM. The radial engine idea is very simple. It has cylinders and pistons mounted radially around a central crankshaft. The radial engine is a reciprocating type of internal combustion engine configuration, in which the cylinders radiate outward from a central crankcase, like the spokes of a wheel. It resembles a stylized star when viewed from the front and is called a star engine in some other languages. The radial engine typically have anywhere from 3 to 9 cylinders. It has pistons, valves, and spark plugs as any 4-stroke engine. The only big difference is in the crankshaft. Instead of the long shaft used in a multi-cylinder car engine, there is a single hub, where all of the pistons connecting rods connect to this hub. One rod is fixed, generally known as the master rod. The others are known as articulating rods. They mount on pins that allow them to rotate as the crankshaft and the pistons move. A radial engine works like any other 4-stroke internal combustion engine. Each cylinder has an intake, compression, power, and exhaust stroke. They differ from inline and horizontally opposed engines in their firing order and the way they connect to the crankshaft. Motorcycles with radial engine. For a brief time, the JRL Cycles Lucky 7 was the only radial engine production motorcycle in the world. The engine is powered by an Australian-designed and built 7-cylinder radial aircraft engine with a swept capacity of 2,800 cc and a power output of 110 horsepower and 160 foot-pound of torque. Radial Hell is another bike with radial engine. Cars with radial engine. The 1935 Monaco Trossi Grand Prix car has a twin supercharged, air-cooled, 2-stroke 16-cylinder radial engine. 2 banks of 8 cylinders were mounted behind each other, with pistons sharing a combustion chamber. This complex engine was light, yet still capable of producing 250 horsepower at 6,000 RPM. In 1939, Plymouth Radial air pickup truck, built by Gary Corns. It is a 7-cylinder radial engine from the early 1950s, producing about 300 brake horsepower. Radial engine in aircrafts. In 1903 to 1904, Jacob Ellie Hammer built the world's first air-cooled 3-cylinder radial engine, which he used as the basis for a more powerful 5-cylinder model in 1907. This was installed in his triplane and made a number of short free flight hops. Another early radial engine was the 3-cylinder Anzani, originally built as a W3 fan configuration, one of which powered Louis Blériot's Blériot flight across the English Channel. Wright's 225 horsepower Che-5 Whirlwind radial engine of 1925 was widely claimed as the first truly reliable aircraft engine. Grumman F8F Bearcat, equipped with a Wright R3350 duplex Cyclone radial engine, is still the fastest piston-powered aircraft. Tanks with radial engine. The Continental R670, a 7-cylinder radial aero engine, which first flew in 1931, became a widely used tank power plant, being installed in the M1 combat car, M2 light tank, M3 Stuart, M3 Lee, and LVT-2 Water Buffalo. The Giberson T1020, a 9-cylinder radial diesel aero engine, was used in the several tanks, while the Continental R975 saw service in the M4 Sherman, M7 Priest, M18 Hellcat tank destroyer, and the M44 self-propelled howitzer. The rotary piston engine is used in some early aircraft, motorcycles, and cars. The rotary aircraft engine was used heavily in early aviation, especially during World War I. A rotary engine is essentially a standard Otto cycle engine, with cylinders arranged radially around a central crankshaft, like a conventional radial engine. But instead of having a fixed cylinder block with a rotating crankshaft, the crankshaft remains stationary and the entire cylinder block rotates around it. Like fixed radial engines, rotaries were generally built with an odd number of cylinders, usually 5, 7, or 9, so that a consistent every other piston firing order could be maintained to provide smooth running. Most rotary engines were arranged with the cylinders pointing outwards from a single crankshaft in the same general form as a radial, but there were also rotary boxer engines and even one-cylinder rotaries. The first practical rotary engine was the Nomo Mega, designed by the Seguin brothers, and first flown in 1909. Its relative reliability and good power-to-weight ratio changed aviation dramatically. Before the First World War, most speed records were gained using Gnome-engined aircraft, and in the early years of the war, rotary engines were dominant in aircraft types, for which speed and agility were paramount. To increase power, engines with 2 rows of cylinders were built. Although rotary engines were mostly used in aircraft, a few cars and motorcycles were built with rotary engines. Perhaps the first was the Millet motorcycle of 1892. Megala is a famous motorcycle, winning many races, which had a rotary engine inside the front wheel. So, what do you think about these engines? Let me know in the comments. If you want to see more videos like this, check out this playlist. Thanks for watching.